guys, it's Mrs. Millison. Okay, let's do the check your understanding on page 46. Okay, write a few sentences comparing the distribution of word length shown in figure 112b. All right, we gotta go back to the previous page. All right, 112b. Okay, what's the difference between these two? This is frequency or count, and this is percent. Okay, this figure is showing how percents are much better to use when you're comparing distributions than counts. Okay, because in this sample, they took 400 words from a journal and counted the number of letters, and they only took 100 words from a magazine article and counted the number of letters. Okay, so our sample sizes are very different. Okay, so clearly everything looks low here. Okay, with the magazine because the sample size is smaller. But if you turn all these frequencies into percentages, the distributions are a little more uniform, a little easier to compare. Okay, so now these are all percentages based off of 100% of the total 100 magazines and the 400 journal words. Okay, so we're going to compare the percentages. Okay, we have to compare distributions. We got to do socks again. So shape. Well, I'm going to say the distribution of word lengths for both journals and magazines, they're definitely both right skewed, and they're definitely both unimodal. Okay, journals seems to have a peak between 3 and 4 letters, and magazines seems to have a peak between 4 and 5 letters. Okay, so that's what I wrote for shape. Okay, exactly what I just said. Okay, you guys can stop this and read it, and then start the video back up. Okay, outliers. So in our socks, we got to do outliers. It doesn't appear that either one of the distribution has outliers, so not going to worry about outliers. So neither distribution appears to have any outlier word lengths. Okay. Center. All right, so we got to find the middle. Now, these are percents, so all I got to do is go to I have to figure out where the 50th percent is. Okay, if I was going to do counts, this represents 400 words, so I'd have to figure out where the 200th word is. And this represents 100 words, so I'd have to find out where the 50th word is. But since they're both percents, I can just do 50%. All right, so I got to figure this out. I don't know, what is that, like 2%? So that's about 13. So total, that's about 15%. A little shy of 25. So 15, 20, 30, 40. So a little shy of 40. So I don't know, like 40, a little less than 45. So probably the 50th percent will be between 5 and 6 letters. So the median or the typical word length in the journal is going to be between 5 and 6 letters long. Okay, so again, let's find the 50th percent here. So what is that? I don't know, like 7 and 15. So what's that, like 20 something, and then 30, 40. So I would think the 50th percent will be in this bar between 4 and 5 letters. Okay, so if the median is 5 to 6 letters here and 4 to 5 letters, the typical word length of a journal is slightly longer than the typical word length of a magazine. Okay, so again, I did my totals, but we also got to remember for relative frequency, we only had to look for the 50th. We had to find where the 50th percent of the accumulated bars are. So the median for my journal is about 5 to 6 letters. The median word length for my magazine is about 4 to 5 letters. So the typical word length is slightly longer for journals. Slightly. Okay, you could have said the word length for magazines is slightly less than journals, whatever. Okay. And then spread. All right, let's see. Journals go anywhere from 1 to 14 letters per word, and magazines go from 2 to 14. So again, not a big difference. So what's that? 13 and 12 is the difference. So again, the variability seems to be pretty much the same. Okay. So I said the variability of both distributions is practically the same, with magazines only slightly lower. Okay. I wrote higher by accident. Slightly lower. Okay, you could have said the variability for journals is, for journal word lengths is slightly higher, whatever, okay? But again, not much of a difference there on the variability. Okay, good. And we'll do more with our comparing distributions. Okay, well, let's see. What was the next question? All right, questions 2 and 3 refer to the following setting. About 3 million first-year students enroll in colleges and universities each year. What do you plan to study? The The graph displays data on the percent of first-year students who plan to major in several disciplines, so business, professional, other, arts, humanities, social studies, education, engineering, and so forth. Okay. Is this a bar graph or a histogram? Well, it's definitely a bar graph. Okay. Why? Because first of all, these are categories. Okay. These are not quantitative variables. And I could rearrange these in any way I wanted. Okay. They just happen to, I don't even know what the order is. They're not alphabetical or anything. So I can rearrange these bars in any order. In a histogram, we cannot rearrange our bars. In a histogram, there's a quantitative variable down here and it has to go from smallest to greatest. Okay, so this is definitely a bar graph, categorical, and I can rearrange those bars in any order. So would it be correct to describe the distribution as right skewed? Well, it looks right skewed, but no. Again, I can rearrange these bars so it looks symmetrical. So when we don't describe bar graphs. Like when we started this chapter, we didn't SOX bar graphs. You just don't do that, okay? You would describe a histogram because a histogram, the bars have to go in a certain order for the quantitative variable. So no, it would not be correct to describe this as right skewed because this is categorical and the categories can be arranged in any order to make those bars be any shape. So we never describe the shape of a bar graph or categorical variables. Okay, hope that was helpful. See you next time.